If you're in the metalworking business, you've heard about plasma cutting systems. Plasma's combination of cut quality, productivity, and versatility make it one of today's most popular industrial cutting processes. But first, what is plasma? Plasma is often called the fourth state of matter. Let's take a look at the three other states we're all familiar with. They are solid, liquid, and gas. The difference between these states is their energy. When you add energy to ice in the form of heat, the ice melts and forms water. If you add more energy, the water vaporizes and becomes steam. From ice to water to steam. But what happens if you add even more energy to the steam? A lot more. If you could heat it to 11,700 degrees Celsius, the steam would break up into a number of component gases. It would also become electrically conductive or ionized. This high-energy ionized gas is called plasma. Plasma is created when you expose a gas to very high temperatures or when you pass electricity through it. Our most familiar form of plasma is probably the gas inside a fluorescent or neon light bulb. Lightning is an example of plasma on a larger scale. And on a very much larger scale, our sun and all the stars are also made of plasma. Plasma is quite remarkable. It has no specific shape. It's also a bit like a metal in that it easily conducts electricity and produces and responds to magnetic fields. Because of these unique properties, plasma can be tremendously useful, which brings us back to metal cutting. Now that we have a better idea of what plasma is, let's see how it works. Here's the inside of a plasma torch, the kind typically used on cutting tables. Compressed air, nitrogen, or other gases provide a source for the plasma. In this example, a second inert shield gas is used to protect the workpiece and blow off melted metal. The electricity supplies the energy needed to turn the gas into plasma. The greater the current, the hotter the plasma. A specially engineered nozzle and electrode constrict and maintain the plasma jet, concentrating it into a small area so it can be used for cutting. When the operator is ready to cut, a start signal is sent to the DC power supply. A circuit temporarily connects the nozzle to the positive side of the power supply with the electrode at negative. Next, a high-frequency spark ionizes the gas and makes it electrically conductive. This creates a current path between the electrode and the nozzle and forms a pilot arc of plasma. The workpiece is connected to a ground through the cutting table. When the pilot arc contacts it, the plasma arcs transfers to the workpiece, melting the metal. The high-velocity gas blows the molten material away. And that brings us to the end of our brief journey into the fourth state of matter.